Okay. Before moving ahead, I want to just ask whether last session we had started with your Python programming. So, and in Python programming, we had started with your basics and we had completed your basics, variables, and conditions. Do you have any queries still so far? We have covered first three things in your Python. No doubts. Then we'll move ahead with your Python basics, which are required for your Raspberry Pi, that are functions, loops, and strings today. Still, I can see people are joining in. So we'll wait for another 2 3 minutes and then we'll start our session. Okay, we'll start. So, what are functions? Let's see, you people have already done. There are built in functions as well as your user defined functions. In the functions, we are going to see stored steps, how the functions stores your different types of blocks and how the flow between one function and other function carries definitions, what are built-in functions, parameters, arguments, and return and void. Stored steps. What do you mean by stored steps in the function? So, assuming I have this program, check the indentations of the program. The moment you run your Python program, the first step, what it is going to execute is this. Since the name it starts with def, it symbolizes that you have a definition of a function. So, a function has def as a starting point, which has a name to it called as thing in this case. So you have definition of function is thing. Below that, followed with your indentations, is the block or the body of the function. So you have two printf statements, which is the body. This will be read by the program, that is your Python interpreter, and it will store it in the memory for the later reference when this function thing will be given a call. Check, this is the body, the declaration of the function or the call to the function. So you should have the definition when the function is called, where the control goes. Then the next thing is the call to the function. So this will be the very first step. It is going to get executed in the Python interpreter. So the moment the thing function is called, the control from the main loop goes to the function. It searches there, comes inside the function, it encounters first print in this statement. So it prints hello, moves on to the next, prints fun. So you have fun. After this, the control automatically will be returned from where it was called. So it will back return the loop to this particular thing from where it was being called. After that, again it will go on to your sequential steps execution. When you have this print statement, again there is a call to the same function. Again the control will be given to the thing function, and then these two steps will be encountered. Check, the flow is this way, how the things are getting stored in the procedures, in the back end of your memory. Now I am mainly focusing on your backends, how the things are stored, where the things are stored, and how the control flows are there, and what the things are used. Check in your Raspberry Pi when you will be writing down a program. I'm not focusing mainly on applications. Everyone is comfortable and everyone is excellent in writing the program and getting down the output what is required. Main thing is over here is what you're transferring, what you're reading, what you're storing, in which fashion you're storing, what is the data type. All those are important. The reason is when you will be connecting the external sensors, what the sensor is sensing and what the actuator is utilizing it. If the sensor is sensing the pulses in terms of analog signals which are converted into digital of ones and zeros, and I read as a string, it would not be detected, because ones and zeros in digital means on and off. So my LED, based on that value, it should be either switched on or either switched off. If I say to an LED, hey, switch on, that content is a string that should be converted into one which should be glowing the analog signal, which will be having passing the pulse rate of the signal, maybe 1 voltmeter or 5 voltmeter voltage each, so that my LED glows. So how the things are stored and how the things are read, that is more important. Hence these all things are required for your Python program. So definition of, and even you'll require the controls from which you're receiving and to what you're giving it. I hope everyone remembers your physics practicals. So in your physics practicals, you used to read it from one input and redirect it to the other input. So you used to connect your wires, your jockey keys, and all those. So similar kind of things you're going to do here. You're going to put your hands for the programming as well as hardware, where you're going to draw the circuits as well as connect the circuits. So the circuits will be nothing but on your breadboards. Your LEDs will be using your jumping wires and maybe more than those. So maybe push buttons, jump wires, and LED screens and all those on the breadboard. So you'll require input from the programming language. where the output would be given to the hardware program. That is a hardware device, external device which will be connected. So definition has been read. The definition stores your function, the block of that function. When it is called, check the control is to and fro. When the function is called, the control goes to the body of the function. Once the body of the function gets completed its execution, it comes back to the same function from where it was being called. Follows the sequential steps. Again, at this point, the function will be called. So again, on this particular thing, the function is called and back. So this is how it is going to be there. I hope these stored functions are clear. Basically, the functions are of two types. Either they are built-in functions or they are user-defined functions. Built-in functions, print was the basic built-in function which is heavily used. Apart from that, we have even seen type conversion functions, if you remember. Type for printing which data type it is. Float for converting an integer or a string to a float. Int for converting an integer, for converting any other data type to an integer data type. Input for accepting it from the user in the strings we have seen. So these are your reserved keywords which cannot be used by as a variable names. We should avoid using this. Functions either can accept arguments or functions. If functions require some input from the external parameters, those are nothing but stored in the arguments of a function. If they don't, that means you're not passing any arguments to a function. Def is a reserved keyword which defines, stands for define itself, defines the function. That means your function definition will start from this point. Whatever the lines below that are there, they are the body of that function. Until and unless the indentation is outwards, one step backwards direction, till that point, whatever is there within that is the body of the function. The function starting is your define function followed by the name of the function and parenthesis. So this is your syntax. Parenthesis may have the arguments or may not have the arguments depending upon how your functions are. For example, this is your built-in function max. Max stores one argument. So you're giving a call to a max function. Check, built-in function doesn't requires your definitions. They are already built in the packages while installing your Python. So moment you call a built-in function, you're just giving a call to it. You're not writing down the definition. If you rewrite the definition of any built-in function, that means you're writing overriding that function. You're making that function to act the way you want. We are not going ahead in the overriding of that or overloading functions. You might be doing it in Java or any other programming languages. Over here, the max is the built-in function. I'm calling the default function, whatever is there in the Python's package. It requires one argument, and that argument type is string, and I'm passing down hello world. Whatever this function has the body somewhere, it goes to the body, executes the body, and returns some value. And that value, I'm storing it in the variable called as big over here. So check, this max function takes up the arguments, it is passed on to the function gets executed. So assume there is a black box where this function is kept. That black box is receiving hello world, doing some calculations and returning back the value. Now, what value it is returning, I'm storing it in a variable called as big. This max function returns you the highest mass ASCII value. What is the ASCII codes of alphabets? ASCII value of small a. We have done ASCII numbers. Your alphabets are stored in the form of ASCII value. So ASCII value of small a. Sure. Small a is 68, Priyanka. Or is it capital A? Or is it something else? Okay. Note down your ASCII values of small a, the range small a to small z ranges from 97 to 122, whereas in capital Z to capital A to capital Z ranges from 65 to 90. Now, since these are your ASCII values, check capital H will be having some value between 65 and 90. Similarly, small p will have between 97 and 122. 97 is for A, 98 is for B, C, D, so on and so forth. So the last character is W, which is nothing but 100 and what is the value of W? So only Suraj can calculate what is the value of W. Okay, there are many. Fine. 119. That is the maximum among the characters that are being passed to the function. So since that is the maximum, check this max function automatically returns you that character, and this is stored in the variable big. When you print, it prints W. Is it okay? Even check min function. What is the min of among these? Check it gives you a space. It is not empty. You're seeing a blank line. Do you have a space over here also? Hello space world. So space is having the ASCII value, which is the least among your these. ASCII value of space is 32. So it prints the space over here, the character. This is clear. So this is a built-in function which has one argument of the data type as string It returns you the max. It does calculation which is already written in its program, stored in a package of Python, and it returns you a character. When you print, prints your values. So this is what I was talking. Hello world is an input to a string. This is your black box, what I was talking about. Here the code, the body, the steps of execution or calculating the max function is written, or this could be your defined function. So this box is nothing but our black box. We'll be doing our calculations, manipulations, everything within that, and we'll be just giving the output, the string, or maybe any other depending upon our requirement. That will be the shown to the user. So check, the user world is familiar only to this part and interested in this part. What you do in this black box, this blue box, blue line over here, is the programmer's thing. So Giardo wrote this program. This code was written by the author, the father of Python. In case if I have to change, if I want to make this max function mine, I have to write down Nita's code over there. If you want to make your code, you have to write down your code over there. So this is the part where the developer develops the things. User, as an external user who is not interested what you are doing within this web. So this is developer's area, whereas an user says, I'm giving you this and I'm expecting this from you. So what you do in this is none of my matter. So, but then being a developer, you need to keep this code very simplicized, even very clear, not complex. So this was something code, assuming this code was written and this gave you the output. Now this is not the code for the max function calculation. It's just the junk code which I'm showing you. Functions of your own. That was a built-in function which I gave you an example. Of your own means built your user defined functions. So you'll have to follow the protocols of the built-in functions itself. So you'll require a def keyword for writing down, for starting down the body. The parameters which are there, those are optional parameters. If you require, if your function reads some input, it requires some input, you'll write down the arguments in the parameters in the parenthesis. Else you'll skip them. This def, whatever follows next, will define your function. So this is the start of the definition. This is the body of the function. Once this completes, your function gets completed. This is the name of the function. No arguments. If any arguments are required, you are going to put up here. Since there is no arguments within that, so nothing. Now, this area is the area for the programmer to write its code on its own. So this is going to define the developer's area. So that function was written x as 5, print hello. I have written down the definition. So this is the program. Whenever print lyrics will be called, this will be executed. Print yo, this. So which is the very first step that is going to get printed? Your Python is going to go into your sequential mode first. So it is going to read your value, store it in X, print hello. So you have hello. It will define the function named as print lyrics. Whatever is the body, it will put up the body in the body loop of that. It will be there. When the print lyrics will be called, only that time this will get executed. Check, I'm defining it, but I'm not giving call anywhere to print lyrics. So this will be never called. Only it is defined and kept somewhere in the memory. Print your x is incremented by 2 and the value of x is printed. So you have these three statements in the output. Check it is print lyrics function is never been called. So if the call is not given, though this is defined, it is not going to react. It is not going to display. There's no action. The trigger is not being given to the function. So you require the event call or the trigger calls. Until unless you do not give a call, it is not going to come automatically on its own. So definition and the uses invoke or a call is important for the procedure or for the function to be executed. This is how your pattern gets stored. Now check in the same program I have done a modification and I have inserted one statement called as print underscore lyrics function. So I'm giving a call. After this print statement, it gives a call to this print lyrics function, the user defined function, and user defined function is being called. Whatever is the output of that is being printed over here. Then the control comes back and increments your value of x and it prints the value of x. Check this line has modified your answer, the output, and the location of the function's print statements. It is not necessary that the function should always have a print statement. So if needed, function could have print statements or function can give a call to another function. That is also possible. So that is called as nested functions. Or the function can give a call back to itself, the same function. That is called as your recursive functions. If you have different functions based on your applications, you will be using all those. In case if functions are required only for calculations or doing some procedure or steps and getting the value and returning it, we can do that also. And in that case, we'll require an assignment operator over here at the call of the function. What are arguments? They're nothing but the input to your functions. Now you'll have to be very careful with the data types. If you're passing down a string or an integer or a float in that fashion only, you'll have to apply the conversions. If you're passing down a string to a function and it is, say, a numerical value, later when the calculations it is required, again you'll have to have the concepts of your typecastings, the type conversions. So you can use that also within the functions or you can use outside the functions. This is the example which we have already seen, the max function which takes one single argument. If it is more than one arguments, we'll have to separate it with commas. This is a user defined function. Based on the function value what you're passing, it is generating some outputs. So this is a definition of a function greet. It accepts some value to it. So lang is nothing but your language parameter which is passed down to a greet function. When this function is given a call, it gives, it sends en. Since it is a string, it sends this string value to this. So when the call is given, this function is called. In the lang, the language argument, it gets stored en. It checks if language equals to en, no. Else if language equals to this, no. Else prints hello. So hence you get the value as hello. So check, the hello is printed by the function and not by the greet. So function call, within the function body you have a print statement. Hence the hello. Similarly, es, fr. So whichever condition gets passed, it evaluates that. Whichever is your condition's value comes out to be true, the body of that particular if statement over here gets printed. So over here, lang is the argument that has been passed to the parameter. Sorry, lang, uh, en is the argument that has been passed to the parameter lang. So en over here is called as the, this en is called as the argument, whereas in this lang which stores it is called as the parameter. The names are okay, argument and the parameters. In the function call, you will be calling it as argument, whereas in function definition, that is termed out to be parameter. Please ignore my handwriting on this slide, though I'm using a mouse. But then I hope it is clear. I'm writing down A as over here argument, and this is your P as parameter over here. The nomenclature is fine because I'll be using throughout the arguments and the parameters values. So you should be clear what I'm talking about. As I said, function could either print the statements then and there itself, or the functions could return the value. Now, this is the other way of writing down a function or giving a call to a function. Check function within a function. A print function, which is a built-in function. Within that, you're calling first the greet function, which is a user-defined function. It will send the control to the function. Function returns hello string. This hello string is returned over in this place. It prints hello followed by so function calling function calls a function, returns a value, comes back over here and prints the statement. Again, next statement, print. Again, give a call to a greet function. Control goes to the greet, returns, comes back over here, prints the value, and prints the another parameter. So you have the output as hello Sally. The control flow is okay. This is the other function where the results are back in the statements and you have conditions also. So function, depending upon your thing, it does the fruitfulness. So return value is required, or the return keyword is important. Check return is your, the ones which are you are seeing in yellow are your built-in functions. The color code which I have used over here is yellow in this case. So wherever you can see these yellow characters, those are your reserved keywords. Whereas in green are your user defined functions, and so on and so forth. So when you see a print statement over here, it gives a call to your greet function and it passes your parameter to it. This parameter goes into the argument and it prints based on the condition, it returns the value. This is fine. Any doubt in this return values? So far the functions are okay with everyone. Are you people there or you people have slept? So only 3 or 4 students are alive and rest all are devicely present. I cannot say physically absent and mentally present and so on and so forth, because now you are devicely present. Your device is present, you may be absent. Okay, I have made you people awoke. So check, my function was invoked and my function has invoked you people. Great. So we have seen what are arguments, what are parameters, and what are results. Am I clear? What the user world is there, it passes your argument. What the function takes is called as parameter. What the output comes is your results. So nomenclature is this. As I said, you can pass more than one value, more than one arguments or parameters to a function. So the function call and the function definition will automatically change based on the number of parameters that you're passing, and it is sequential from left to right. So when the function call is there, in the function call, I'll be having those arguments over here, 3 comma 5. So I have two arguments. The value 3 gets stored in parameter A, value 5 gets stored in parameter B. So whenever these values are being encountered in the respective function, those values are automatically referred. So the parameters over here are passed as two parameters. So hence they are separated by a comma. Even the arguments at the pass of the arguments, it is separated by a comma. So when this function is called, it returns the addition of those functions. So addition of the value of a plus b, that is 3 plus 5, is returned back in the function and it gets stored in the value x, the variable x. The variable, when it is printed, you get the value of that particular function. In case if you are not returning, if the function is not returning anything, you can have the function preceded with void. Void simply means null. That means it is not returning anything. When to use functions and when to not. So this is important when you will require functions. When you want to keep your code organized, when the same bunch of statements is reused again and again, at that time you will require functions. If something is too long and complex, at that time you can use your functions. You can make a library of those your self-defined functions and can include in later use of your programs. What do I mean by this? This will be very helpful, and this is called as modular programming. This modular programming concept can be utilized in any programming language which you have learned so far and will be learning in future. Everyone knows how to I'm just concerning about your Python and I'm taking up the example of Python. Which all import libraries you have used in Python so far, or you're well known to that? Any import library you are recalling it? Any import statement of any Python program? Don't worry, I won't be asking you the details. Just I want the names. Pretty good. Few of them have said math library. So importing math library, everyone has written that statement. Now check, this library is already built in. Somewhere that math file is already stored in the Python package. That math file was written by somebody and that was nothing but our Guido. We have to write our own function, my user defined function. So if I write a program, say for calculating addition, for calculation of multiplication, for calculation of division, all mathematical operators, my all six mathematical operators, six different files. Now whenever this will be called in my bigger application where I need a calculation, say calculation of your Fahrenheit, addition remains same throughout, multiplication remains same, it takes up two parameters, two operands, operand 1 and operand 2, applies the operator and returns the value. So the code in pseudocode remains same for every operator. So in that case, why not I pass all three parameters? Operand 1, operand 2, and the operator. Once I do, Operator will automatically be read. If it is multiplication, it will send the multiplications result. If it is addition, it will send the additions result. Check in all five operations, these three parameters are common. Value of two parameters, that is value 1 and value 2, operand 1 and operand 2. If I have to apply an operator of addition, I'm sending the operator as addition. If I'm sending it multiplication, it will return the multiplication results. So then at that chunk of code where it reads the operator, where it reads the operand 1, where it reads the operand 2, that will be written down in a file. That file will be directly just imported into the program where it is required. If you have tomorrow, if you are a good programmer and you have thousands of codes to be written down for different applications, so you're not going to have a face problematic over them. So if you have to write down 1,000 codes, 1,000 files, and out of those 1,000 files, 550% of those files are giving an evaluation or the calculations thing, you require a calculations. So directly that importing facility will help you. No need of rewriting down that same bunch of code in 500 different programs. I'll have to write only one single statement, and that is import statement to that particular library which I have created, the user defined library. Similar to what already you have written down, which is already present in my Python, and we include it as an import statement, which you already gave an example to students saying the math. So import math, when you do, it automatically recognizes your sine function, your trigonometric functions, your calculations, and so on and so forth. Absolute, round, seal, and many more to go in the library. So similarly, you can create your own functions. You can create your own files. Those functions will be there in those files. You need to just import that file and give a call, and your job is so easier. Functions are so strong and so useful. Hence, when the program gets too long, long in the sense of lines, number of lines, and I want to break into the logical chunks. So say suppose input file is one file, then clearance, that means after inputting it I have to convert them into my conversions, the type conversions. If in any case if I have to require, then I'll write on another file, then the third file which will be actually calculating it, and the final fourth file which will be an output file. So check, you have four different files, only one main file which will be calling again and again. Input is an input reading required for everything. Second file clearing, conversions required for every application. Third file, which is function file, the main calculation file, only that code depends, that keeps on changing. Whereas in first file, second file, and fourth file remains same in every application. So tomorrow, if you're building up a project, every student, if I have 85, no, 84 students today, I have 84 projects. 84 projects, each student will have first, second, and fourth file same. Whereas in third file, which is their logic file, will change depending upon what application, what project they have choose. So check, my life would be easier when I'll write down every file in the different modular functions. So when this kind of programming when I'll do, I know yes there is an error. Where the error is, say suppose at the time of input. So I have to look up only in one file. My life would be easier. Else, if I write down everything in one file, I have to keep on searching which file, which line it is, where that input statement is there, which field it is there, which parameter is giving me a problem. So one file with many codes, it will run. It is not a problem. But then the when the error comes, the solving of that an error is a troublesome for a developer. Developer will find it out and it will do it, but it will be time consuming. Same way, when I'll be using my library functions or when I'll be creating a modular files, it will be much easier. That means I have to look up only to a small chunk of code, and that too in one file. If there is some problem in display, then I'll have to look up only in the fourth file, that is the output file. If there is some problem in the value transfer, then I'll have to look up only in the conversions file. If there is a problem in logic calculation, If I have passed an operator plus and it is giving me multiplications results, then I'll have to look up only in one file, one area of the code. So hence the functions and the modular functions concepts are more important for future use. So when to use functions and when not to use functions are clear. So in the functions, we have seen what are functions, built-in functions, parameters, results, and that is your return statements over here. Fruitful functions were nothing but return statements. In case if you don't have any return statements, then we are using void and when to use your functions. With this, we complete your functions part. Quickly take the screenshot of this. What functions are needed in Python? Any query in functions? Okay, screenshots are done. Any query in functions? If no query, then we move ahead. Shall we move on to loops? In the loops, we are going to see your especially while loop, what is infinite loop, what your break and continues does, what is for loop, and what is iterations. Loops are even called as repeated steps. That means it will keep on repeating the same thing, looping again and again based on until unless it falls the conditions or not. If it doesn't falls the condition, it will be going into your infinite loops. Over here, let's see with an example. I have a program written down and is storing the value. While is the function which checks the value. If the condition is true, it goes inside the while loop, does its job, again comes back and checks the value. If the value condition again is true, again it repeats. This goes on until and unless this condition doesn't fails. Once the condition gets failed, it comes out of the loop and does the sequential job. Over here, n is storing as 5. Is 5 less than is or greater than 0? 5 is greater than 0. The condition is true. Since the condition is true, it goes in the loop. It prints the value of n, that is 5 in this case, decrease the value by 1. Now n becomes 4, goes back again to the condition and checks 4 greater than 0. Again the condition becomes true. Yes, it comes and prints the value new value of n, that is 4, decrements again by 1. Now the new value of n is 3. Again goes back to the condition, checks, condition is true. Yes, comes inside the loop, prints the new value of n, decrements the value, and it stores back in n. Now n becomes 2. 2 is greater than 0. Condition is true. Prints the new value, decrements, true, prints the new value, decrements, 0 greater than 0. Condition fails. When the condition fails, comes out of the loop and does the next sequential statement job. So this is how the looping goes. In the while loop, check every loop. has three things in common. Whether you take it up a while loop, whether you take up it a do while loop, whether you take it up a for loop. Only the way of calling these three things is different. The first thing is what every loop requires. Do keep in mind, in any programming language, anywhere, this is a thumb rule for any loops or any repeated steps. It requires first the initialization. Over here, check, the initialization is done outside the loop. That is the initial value, the parameter, the condition parameter that is going to take. Next is the condition. Second is condition. So based on that condition, the loop either goes in the true block or it goes in the false block. And based on the condition, you have the third thing as either the increment or the decrement. So either the value of the initialization variable will increment or decrement based on the condition. Three things that are required is initialization, condition check, third is increment or decrement. So this three things you need to keep in mind. In while loop, the initialization is outside the while. Now since this while loop is taking the condition as variable greater than 0, hence there is a decrement called. Assuming n was 1, in this case when n is 1, I'll have to check n greater than n less than, say suppose, 5. In this case, my print statement n, and now I'll have to increase n based on the condition. So check, you have the lowest value, you're checking up with the less condition where you have increment. Over here in the other side, you have the highest value, you're checking up with the greater than 0 and you're decrementing it. So based on the condition, either you can have the increment or you can have the decrement of the parameters. These two things are okay. Three things what are compulsorily required in the function in your loops. When I do now check in this program, which thing which is required is not present over here. Just now I stated three different things which are required for every loop. What is missing? Have a cross check on this program. Do you have initialization statement? So only one student says yes, one initialization statement is there. Do you have condition statement? Do you have either increment or decrement statement? Now check. Compulsory conditions were these three, out of which one is missing. You neither have an increment, you neither have a decrement. That means the variable what was initialized and the condition, if it is true in the function for the very first time, that only remains static. There is no increment, there is no decrement. So in this case, when my value of n is 5, it is true. It comes and checks. Is 5 greater than 0? Yes. Since it is 5 greater than 0, it prints this, prints this. Again, it goes and checks the value. Now check, the value of n is static, it is not altered, it is not having neither increment nor it is decremented. So in either cases, the value of n never changes and the condition never changes. So this loop keeps on repeating itself. So this is a problem and hence it is an infinite loop. This is fine. So since there is no change in the value, it is infinite loop. Quickly punch down your PRNs. Infinite loops are fine. Can you tell me the output of this particular program? Is it an infinite loop or not? If no or if yes, tell me what is the output. So you have two questions. First of all, whether this program is an infinite loop or not. No infinite loop. Check, the third condition is missing. There is no increment, there is no decrement. I have initialization statement. I have conditional statement, but then there is no increment or decrement statement in the loop. Still, you people are saying it is not an infinite loop, except one. One is saying yes, it is an infinite loop. So those who are saying no, can you justify why it is not an infinite loop? Correct. The condition is false. Tanuj, 0 cannot be classified as positive or negative, so it's not yet defined. The proofs are not there. So in case if you come up with saying hypothetical proof saying that 0 is positive, please do share with us, at least me. So condition gets false over here, that is true. So the value, the loop never hello there is printed, hello there condition is true, inputs, checks whether the entered value is hello there equal to done. Since this if is false, it prints hello there. Again, it goes and waits for the user input. User inputs finished. Not true. The condition of if block decision block fails. So no break is executed. It prints finished. Again, it keeps on waiting for the user to input. Now user puts up done. Since the if decision is now getting true, it breaks. Now this break is not for this if block. This break is for the loop. Now check the if where the break is called is having the parent call of while. So within the while you have if, within the if you have break. If is going to be true, it is going to give a call to the break. Break is going to check who is my parent, who is my immediate parent, who's at my top, from where I was being called. That is while, and it breaks out and it comes out of the while loop. This is clear? The break. Now this break terminates the iteration, immediately comes out and jumps out of the loop. In case if you want to skip only one iteration, you don't want to completely end up the loop. If you want to completely end up the loop, you will use break. If you want to just skip one iteration, in that case, you're going to, this is how your break gets executed in the flowchart diagrams. In case if you want to skip one condition or one iteration, you'll use continue. Continue just ends that current iteration and it moves ahead. Since while is true, waiting for the input, if line 0 equals to hash, continue. That means the starting character. Now I hope everyone knows line 0 what it means. It reads the full line string. Line 0 means the first character. If the character of the string starts from 0, yes. If it starts with hash over here, the first character of the string, is it hash? No. If no, it moves ahead. If yes, it will come in continue. So check. Initially we have hello there, which is inputted. If line 0 is the first character hash in this case, no. So it will go on the next if. If line equals to done, is this whole character done? No. It prints the line. That means hello there is printed. Again, it goes back to the loop, being the condition always true condition. While line equals to input, it waits for another input. Now the next input of the user is hash don't print this. So this is what the user has entered. It comes to the line 0. Does the first character of this line, is it a hash? Yes. If it is hash, it continues. Now this continue is going to continue the loop. That means again it is not going to go and check with the done. Over here it is going to break the if statement, if block, it is going to return the control back to the true from the start. Again the prompt waits for the user to input. Print this is the next input. First character is not hash. The line is not done, so it prints the line. Again this keeps on doing until and unless you do not put up either done or you don't put up hash. Check when your Python interpreter reads, and if you have written down comments, is it not this function being called? Whatever you input, it is printing. When you have completed, it is done. Whenever you have hash, it is skipping, it is not doing anything. So comments are being read. It is being read in the input. Its line stores the contents, but then it is not performing any action because the first character is hash. This is what your interpreter does of Python. The moment it encounters first character as hash, it has to skip the line. And this internally the interpreter generates your automated machines. What you're doing it in TOC, this is being done by defaultly in by every compiler or an interpreter of any language. Things are clear. There is a announcement to be made. Few students, when the parents are asked for the punching, if you do not punch within that time and you keep on later on punching, it would not be registered. The reason is, when we say you to punch, the code is written on the server where it punches, asks you within that time period. So it is time based punching. So if you keep on punching later on also, it is not worth. Other thing is, do not put up multiple times your PRN. Put up once only. Okay, that was the announcement to be made. Done with that. Moving ahead. Break and continue are okay. This is your diagrammatical or flow representation of continue. Indefinite loops. These are those loops which never get terminated. That means the condition is never false. So if such kind of things happen, and check, your IoT will be your server based programmings. Now though you're learning it Python over here, we'll be writing down a Python, but then this code would not be run executed on the client side, it will be run on the site. Now the client side can be the site itself where the actual applications are installed of IoT, or it can be another third place itself which you never visit as a developer, but then still it is being used. This is what an IoT platform is. Being a programmer, I may visit, I may, as a developer, I may go to client's place who has ordered, who has hired me for building up my IoT application and writing down a program for him. But then that is not a place, it may or may not be a place where the same installation of the hardware part is done. So in that case, I'll have to think of those scenarios and be careful with the indefinite loops. If it is an indefinite loop, it is very dangerous with the IoT. The reason, it takes up that many space in the server. It is running on a third party machine which is unaware by you. That means you're not aware of the OS, you're not aware of the status of updations of the packages of the operating system. You're not aware which peripherals are used, what are the conditions, and what type of connectivity of the internet over there it is. So all that keeping in mind, you'll have to be very careful. You cannot have a bad code written or a bug code written with the indefinite loops, as if it is real time operating systems. So these are very critical applications. So being a programmer of an Raspberry Pi or an IoT application, you'll have to be more and more cautious than a normal developer. Normal developer, I mean, a one who is working on the desktop or on the backend. They can be preserved because they are familiar to the systems, or they can go at any time and have a client's meeting and visit over there. But then this is a remote access. You may be sitting over here in Mumbai and your application is on a higher altitude where you cannot go, or you're restricted in the defense area, you cannot go. Say, for example, at LAC. So, if my application is running at LAC, I'm not having a permission to go on LAC. So, in that case, I'll have to access the remotely. So, there we cannot have such kind of codes which are running into an indefinite loops on so on and so forth. Or if you have some health problems and you cannot visit, maybe at higher altitude away from your Leh and Ladakh, that side. So in those cases, you'll have to be very careful as an IoT programmer. Always see to it you have definite iterations, a set of loops which are written over there. Definite means it may keep on repeating n numerous times, but then there is a limit. It needs to stop if the condition gets failed. I don't mean that if the condition is true, you should stop after 5 iterations or 6 iterations or so. If the condition is not really needed, it should have an stopping position. Check in this, you have a stopping position. It can read new loop. Check you have an iteration I, the range of I. If I falls within this range, it will keep on taking one after the other, and it will keep on incrementing. Now this is a speciality of for loop. For loop internally has initialization and the increment default until unless you do not want to change. The default initialization of a for iteration variable, I in our case over here, is 0, and it always increments by 1. So this is a standard default for loop. In the while loop, you had to define your initialization step, the first step, and the third step, that was either the increment or decrement. In case if you do not want to define, you want to go with the standard ones, you can use for loop, which is an alternative of while loop. But in case if you're using while loop, it is compulsory for a developer to initialize and increment or decrement based on the condition. Now check here also, though the initialization and increment decrement statements you cannot see, but then they are automatically done the moment for is being called. So again, it is present in the built-in package. Since for is a keyword, the moment your Python interpreter reads this, it automatically fires I equals to 0 and I equals to I plus 1. But then they will be called accordingly. So I equals to 0 once it is initialized. So first value of I in this particular range. So it takes up 5. Once that statement of the block is completed, now the iteration I equals to I plus 1 is called. It moves on to the next. This keeps on doing until and unless it finds the last value. Once it is having the last value, there is no value within after this, it will break the loop automatically. So this is how your for loop works. So you have a defined iteration, hence the loop becomes definite. Once the loop is completed, it comes out of the loop and prints your regular sequential statements. Check. Here you have a list which is defined as friends. You have the list of friends. With every friend, you're wishing some greets over there. So this friend is an iteration, whereas in these friends is the list. So in the for loop, first variable, you'll have a iterative variable, that is an iteration, single iteration, whereas an in keyword will define your whole block or whole loop space where all the variables or all the values are put up. So this is a set friends. From that set, you're retrieving one at a time. This is your graphical or flowchart iteration model of your for loop. This I have already explained. I is nothing but called as your iteration variable, whereas in this is nothing but your 5 element sequence, that is a list. It is going to look the value of I within this particular sequential block, and if I lies within that, it is going to go ahead. If the values of I gets terminated, it is going to break the loop automatically. Check, I will be storing the value 5. It is going to store the index value and not the actual value. So if it is indexal value, the count of I is 0 initially, yes, it prints the value. Print I prints the value. So you have the condition on the counter check of the index and the value. This is how it executes in the real world and the back. So when you write down for I equals to 5 comma 4 comma 3 comma 2 comma 1 and print I, check in the program. As a programmer or a developer, you're writing down only two statements, but in the background, the hardware, the CPU of the Raspberry Pi has to evaluate this. Initially, I is taking the first value, prints. I is taking the second value, prints. I is taking the third value, prints. I is taking the fourth value, prints. I is taking the fifth value, prints. I doesn't have a new value after this. So this condition gets false. I cannot move ahead with I. Done? Yes, I'm done. It comes out of the loop. So this keeps on doing until and unless if the next iteration of I is present. If I can move ahead in that particular sequence, in that particular range. If yes, this will keep on looping. Else it will come out. So within the two lines, check how much block of sequential lines it is executing. So one way was either printing down these 5 cross 2 10 lines or 2 lines. So though as a developer you have cut short the number of lines, hence Python was preferred by Raspberry because it has less number of lines to be written down. Check, within 2 lines you are executing 10 lines in the background. Am I clear? When you execute this particular loop, now your iteration values are different, whereas in your things are different. So before and after statements can be printed. Check in this case what I was talking about. Now I have a counter variable zoc. I'm initializing it to 0. Initially, before the loop begins, the value I'm printing of that particular variable, which is 0 in our case, for thing equal in this particular range, I'm printing the iteration number, how many number it is there, the count, and I'm printing the value. With the first iteration, the value is 9. With the next iteration, the value is 41. Similarly, next iteration, 3 and 12. Next iteration, 4 and 3. So the value of zoc is nothing but the iterative value, that is the index value, how many number of elements are present in that particular sequence. And thing over here in the loop is the actual value of that iteration. So the ones which you're seeing in blue are nothing but your counter variables, counting how many number of items or how many number of iterations are present. Check after that it is not incrementing. Once you come out, you have the static value which says that these many number of reads were done from the sensor. So counter, you will have to keep it up when your sensor is sensing the data. Sensor senses the data in hundred and millions times in within milliseconds. It reads the data very quickly. It is lightweight component and it doesn't requires more energy. So it is low energy based components, peripheral areas. So The moment I am speaking and your brain is processing that for the understanding, within that time my sensor senses more than thousands of iterations or millions of iterations. Now I have to read all those. So when I have to read all those, I need to keep a track of such kind of iterations, how many things are being read, how many values are being read using the counter variables. So counter variables will be required. So counting down a loop is okay with a for loop. So with the loop, either you have a counting or you can sum up. You can find out the sum of the iterations. If I give you these values and I need the sum, you have the sum. So two major, you can say, the functionalities of a loop. Loop helps you in counting. Loop helps you in summing up to the previous values, sum of n natural numbers, of sum of n even numbers, or sum of n odd numbers. You have done all these programs, so I'm not going into depth. So you have some equations, some sequences, maybe an arithmetic progression sequences or a geometric progression, APs or GPs. Based on those, your loops will help. So loops are basically used for counting, for summing up, for finding out your averages. Check your stats are there in this statistics. You find frequencies, averages, filtering in case if you do not want to check, if you do not want the numbers, you want to check from the range what is the highest value and what is the lowest value. For example, let's take up your Raspberry Pi's famous sensor of temperature, which is required. So how is the highest value so far recorded in your area for COVID-19 patients? What is the highest body temperature that is recorded? So in that area, if the sensor is there already and the people and the humans are passing through that particular area and the sensor is sensing the body temperature, I have embedded a body temperature over there. The moment anyone passes, it records its body temperature and it sends it to my machine. Now out of that, I want to check what is the highest. So it will, I'll have the program to be written down, and automatically once the program has detected the threshold value saying that, so if it is 96 degrees Celsius, allow the person. If it is higher than 96 threshold, I should reject the person. I should not open the block, the door. The door should be locked, and there should be a burglar alarm in the red indication that this person is having a high fever, so please check him, or maybe some precautions to be taken down. So in that scenario, my loops will be written down over there. So in the condition, I'll be accepting a sensor will read that data, I'll be storing that data in the count in my some database or in some files. In the backend, I'll be checking the value. If the value is on the threshold, below the threshold, or equal to threshold, the door will be open, the person will be allowed to go in. Or if the temperature is high, the door will be locked itself and the LED will glow saying, stating that please take him for a cross check or take up the preliminary precautions. So this is where such kind of programming and IoT is going to help. Now I have taken it as a live example which all of us are facing right now. So every time you need such kind of things, and I cannot keep on going over there again and again for the check. So in that case, this will be helpful. Now check, even I can have this rather than taking up the the LED which I was talking. The LED has to glow in red. LED knows only analog signals. Either you have a 5, if a LED has the positive and negative voltage, it has only two things. Your fan is also an analog signal acceptor, so it takes up either the high value or it takes up the low value. Now this is in terms of analog, high value and low value. As a digital person, as a programmer, my program knows only digital values, ones and zeros. So high is 1, low is 0 for me. So my 1 should be converted into high. That means my full voltage, if the LED takes up 1 volt, my full current volt should be given to LED and the LED will glow. If no, I should give a 0 volt. That means my current should not pass in that particular pathway. That means if you remember your physics practicals where you have to pass the current to glow your bulb, you used to insert a key to join the circuit. If you remove the key from the jockey, that means your circuit is broken and the current would not flow in that direction. I hope everyone remembers your parallel and serial connections of this. So same thing you're going to use over here. Physical also, where I'll be now there is no physical key over here. Now that you have to control based on this if condition loops. So if my value is equals to 0, my current should not be passed. That means if the body temperature is equals to 96 or less than 96, my LED current should not be flown. So LED will be 0, passed value, digital value 0. Once it is digital value 0, that means 0 voltage in the flow should be passed in the analog. So automatically the LED would not glow. If the temperature is higher, greater than 96, my LED value will be 1. So since it is 1, my full 1 voltage should be passed and my LED should glow. So that on and off of LED based on the current pass of 0 and 1 values of digital, it should be converted into the analog signals. So digital to analog conversion and analog to digital conversions are important. And all of this will be done on your networking. I'm passing through using your networks. So I'll require the address where it is to be sent, similar to your normal letters if you want to send. So if you want to send, post a letter, or if you want to send a WhatsApp message to a friend, you require the address of that. So address in our case is phone numbers or the postal addresses of the physical location. But then in networking, that is nothing but the IP address, that is Internet Protocol address of a machine. So when even you logged in for this Google Meet, your from which device you have logged in, the IP addresses of those devices are already registered on to us. So if you log into through different IP address, you will be easily traced out that saying that you are not so and so person, not logged in through same device. So that could be, that is even kept a track. So this is how the loops are more efficient and more critical usage of your programming languages with Raspberry Pi. Quickly take the screenshot of this. We have completed with the loops part. And in if case any queries related to the loops or few just examples I have just taken up the top overview examples how I can relate my Python loops to real world IoT applications. Are those applications, can you figure it out in your imagination how the things and the flows are working? May not be in depth, but then the concepts are okay because you're going to see all these examples in depth. So when I'll be discussing the case studies, at that time I would not mention that this programming is used and this particular iterations or this particular loops or this particular conditions are being checked. That automatically you should understand that it is written by a developer and what the developer requires. Now, since you're new to the IoT, hence I'm giving an elaboration over here. So any queries in the examples which have been taken today? The case examples of IoT? Quickly let me know in the chat panel if the screenshots are done. Just put up SS done or done. Fine. The last part is your strings. In the strings, this is important because if I want to read and I want to print, as you have in on your railway stations, printing of those values, this train is up and this train is down on this particular time on this particular platform, the traffic signals displaying the information, or the banners or the boards, you require such kind of things. So strings are used in those IoT applications where you need to print something. Either it could be a static print or it could be a scrolling print on a LED, that is your 8 clock LED, or on LCD screens. So for those, you have two different sets of printing. LED printing is different and LCD printing is different. But then I'll require strings in both the cases. So strings concepts will be done and taken care by your Python. How to print on LED and how to print on LCD, that will be taken up by your hardware part. So before that, let's see what your LCD is gonna print. It's a string, either in double quotes or single quotes. Even we could apply these string operations. Plus is used for concatenation. So if str1 stores hello, str2 stores there, and I'm adding string plus string, it is going to generate a new string. Now check, there is first string appended with second string. Hello forwarded by there. So there is no space between them. Similarly, I have a string 123. Since it is in single quotes, though it is an integer, but then it is stored in the form of string. I cannot have this because this is a numeric integer, whereas in this is a data type. So first I need to convert this, and then I can apply the addition method. Reading and converting. Input, default function required for inputting, taking the inputs from the user. So based on the inputs, you can write down your programs. So if the name is entered, you can print hello so and so. Now check. When this is there, though the amount of that particular product is being asked to enter over here, it shows in the variable. Though the value is integer value. But then that again is a string. I need to convert this 100 to a string for applying the arithmetic operations. So you need to apply, else you'll get unsupported operands of string and integer. So this is important. When such kind of statements comes, my try and except block will help me over there. If it is not an integer, what is to be done, and if it is an integer, what is to be done. Then only your arithmetic operations will be fruitful, else it will give you an errors. Similarly, when I have this string in the memory, the string gets stored as a character. When you enter, you are entering it as full string. But then when it is getting stored in the memory, each character is stored in the separate position, though it is in continuous fashion. That is in conjunction, one after the other. So you have the variable fruit, and when I say one, check, it is going to have the iterations. These are your counters to that string. By default, it starts with 0, and it's the length of this particular string will be n minus 1. So the length is 6. 1, 2, 3, 4, 5, and 6. But then the iterations will be n minus 1. So it's because it starts with 0. When you print fruit 1, check the square brackets. Square brackets are the indexed brackets in Python when it is used with strings. So these brackets are called as index brackets, which specifies the index of that particular character within the string. So if I put up fruit 3, what it will be printed? So 3 is going to print again the value of the third index, that is 0, 1, 2, and 3. A will be printed. You have built-in functions of a string, length, fruit. Now check iteration, since I said it will start from 0 to n minus 1, whereas in length is n. So length of the string is 6 in this case, n minus 1 you have iterations from 0 to 5. So you have built-in functions of string as well. So again same what we had seen for the max function. Input is string. I have a black box over here which has a function definition of length. It reads the string, calculates the length of that string, and it prints the integer. It returns the integer value, that is the number of characters, the length of the string. So the program is written down within that. Similarly, your while loop, when I have a string index less than the length of the string, it will keep on looping and it is going to follow that particular. So loops can be applied with these strings, either the for loop or the while loop. Now, this loops we have just now seen in depth, so hence I'm not discussing over here. Check letter, each individual letter is printed. Now, this fruit is the sequence over here. If you remember in your previous program, we had for I in range, and that range was some numbers which was a list separated commas. Now, this is also same. In the fruit, it is going to store single quotes B, single quotes A, single quotes N, single quotes A, single quotes N, single quotes A, continuous separated by commas, and each character will be retrieved and the each letter will be printed. So I don't have to worry about putting up that sequence separated with your commas. Automatically this string has a built-in facility within the Python package and Python interpreter does for us. Same way, because of loops, again the same concept of loops, counting, calculations, averages, and all those we can do over here. And this is what I had explained, iteration variable and the six sequence iteration. This is how it stores. So internally, when the letter is there, this is replaced and each individual character is being taken and the letter is printed. Colon operator is used for slicing. When I say 0 to 4, from this string, it will start from the 0th index and it will complete till the fourth position. So first, second, third, fourth. So it will stop till here. First four. So first is your starting position. Next is how many numbers you want to print. So first value prior to your colon is the starting value from where which index you want to start. That is 0. Fourth is till how many next positions you want to print. So 0 will be printed in first, second, third, fourth. So it will stop till here. So 1 less than this. Similarly, when it is 6, it will start from P. It has to stop before 7. 1 less than this. So it will going to print only 6. Similarly, from 6 to 20. Now check, there is no character after 11. So it is this string gets terminated over here. Still it is going to accept it. So the upper bound is not there. So it is going to print only the string, the full length of your string. It will automatically stop after 11 because the end of the string has been reached. Slicing of strings is okay. Your next instructor has arrived, so we'll stop over here. In the next lecture, we'll continue with the part of the strings. There is a small announcement. Your reference books of IoT are being uploaded on your LMS site, so you can visit and download those PDFs. I have just given the reference material, so you can get it done. Those are your reference books mentioned in your syllabus. Hina ma'am, you can take over the session.
Yes, ma'am. Thank you. Good afternoon, everyone. Am I audible? Okay. So let's begin. So in last session, we have seen how to convert an NFA into an equivalent TFA. So we quickly repeat the process of converting NFA into an equivalent TFA because we have two more examples to convert NFA into an equivalent TFA. So let's look at the steps first. So the first step was construct the transition table for the NFA machine. First step was to construct your transition table for a given automata. Then the next step was, can anybody help me? What was the next step? Yes, we have to create the transition table for DFA, right? I got one answer. Just a minute. state. So there was a step that if we have any step in two states on a single block, we can create a new state and create the new state. And the fourth step was next state of this constructed state on input symbol will be the union of next states from the NFA transition table for the same input symbol. We were supposed to take the what is the initial state? Which one of them is the initial state? And what about the final one? What about the final state? So we have three states, Q0, Q1, and Q2. Q0 is an initial state and Q2 is a final state. So to construct this particular machine into a table, we have a table-like structure with three states and two inputs. As you can see, there are two input symbols, 0 and 1. So we'll construct such structure and fill the entries according to the transition, right? I hope you remember the steps. Can you fill the entries for me? Q0 on 0. Yes. Q0 on 1. What about Q1 on 0? Q1 on 1. Q2 on 0. Q2 on 1. Okay. So these are the entries, right? Almost all of you have answered correctly. So can you see there are two problematic entries? Q1 on 0, it is moving to two states, that is Q1 as well as Q2. And Q2 on 1 is moving to two states, that is Q1 and Q2. So such things are not allowed in DFA. So for these two problematic steps, we need to follow the steps for converting NFA to DFA, right? I hope you remember the steps. Now, but we have to find the entries of Q1, Q2 on 0 as well as on 1. So I'm going to add one more entry in my DFA table, which is Q1, Q2. That is my new constructed state. Check here. Can you tell me where Q1, Q2 will go on 0? Yes, anyone? Q1, Q2 will go on 0. We have to find the union of these two. Q1, Q2 on 0. I got only single answer. Okay. Yes. So check here. Q1 is moving on Q1, Q2 on 0, and Q2 is moving on Q2 on 0, right? So we'll taking by taking the union of these two, we got Q1, Q2, Q2. But since Q2 is coming twice, so in union we'll avoid such term, then we'll write it as once only, right? So Q1, Q2 on 0 will move to Q1, Q2. And what about Q1, Q2 on 1? Yes, where Q1, Q2 on 1 will go. Just same, that is Q1, Q2. We are getting Q1, Q1, Q2, but we'll write it as Q1, Q2, right? So here are our new entries. Q1, Q2 on 0 is moving to Q1, Q2, and Q1, Q2 on 1 will move to Q1, Q2. Check the last row. Do we have any problematic term in the last row? Q2 on 0 is moving to Q2. So no problem. Q2 on 1 is moving to Q1, Q2. Is it a problematic? Can we copy down the last row as it is, or we have to do something else? Yes. Q2 on 0 is moving to Q2, so no problem. Q2 on 1 is moving to Q1, Q2. Q1, Q2 are multiple states, but we have already created this state as a single state, right? So we'll consider Q1, Q2 as a single state and we'll copy down the last row as it is. Okay, so I'm copying down the last row as it is. Before that, there is one more step. If you're creating any new state, constructing any new state by combining two or three, if any of them is a final state, then that new state will be your final state. Okay. So check here. So I'm making Q1, Q2 as a final state by putting a star and we'll copy down the last row as it is. Is it okay? Do we have any problem till here? Or all the steps are cleared? We have already seen this example in that session, but there were so many days in between. So I just, okay. So now you have to take this DFA table and construct that into a machine. I think you are good in that, right? So in your DFA, there will be 4 states, Q0, Q1, Q1, Q2, and Q2. Okay, check here. This is my DFA table. I'll start with Q0. Q0 on 0 will move to Q0. So we'll have a loop. Q0 on 1 is moving to Q1, right? So Q1 on 0 is moving to Q1, Q2. That is a new constructed state. So we'll write Q1 on 0 is moving to Q1, Q2. And I made it double center circles because it is a final state also, right? So Q1 on 1 is moving to Q1 only. So we have a loop. Q1, Q2 on 0 as well as 1 is moving to Q1, Q2. So we'll have a loop for 0 as well as for 1. Now there is another state Q2, right? Q2 on 0 is moving to Q2. So there's a state Q2 which is also final state. And on 0 it is moving to itself. On 1 it is going to Q1, Q2. Okay. So can you see we cannot reach Q2 by any way through the initial state. So such states are known as what? We have discussed this term. Can you please term what is the Q2 state? Can anybody tell me how do we address Q2? Can we reach Q2 by through initial state? I got only one answer. Yes. So it is an unreachable state. Okay. So we have seen different states like terminate state, right? Dead state, and that is an unreachable state. Is this example clear? Shall we move to the another example? Okay. Let's check. This is another example, converting NFA to an equivalent DFA. The example says the language which NFA is going to accept is a set of strings over 0, comma 1 that starts with 0, right? So we'll quickly construct NFA first, as the diagram is not given, just the definition of language is given. So we'll construct NFA first. How we are starting? We'll start with the initial state, right? So tell me initial state is Q0. Q010, where it will go? Q1, will it be the final state? Yes. So Q010 is moving to Q1. That is my final state. Is this thing is enough for constructing an NFA, or we have to put something else to finish my NFA? Since it is starting with 0, so we'll start with Q0, and if the symbol 0 will come, it will move to the final state, right? Okay. So is this enough? Will this NFA accept the language over 0 and 1, which will start with 0? No. It will accept only 0, right? To accept all the strings starting with 0, we have to put the loop on Q1, right? For 0 as well as 1. So check here. There's a loop on Q1 for 0 as well as 1. Since this is an NFA, we will not take care of the completing each state. So we are not going to draw a transition for 1 on Q0, right? So this NFA is enough to accept all the strings starting with 0, right? So we got the diagram. So our first step is to convert the diagram to a transition table, right? We have two states, that is Q0 and Q1. Q0 is initial and Q1 is final. And there are two inputs, 1 and 0. Check here. right? Let Q0 on 0 will go. What about Q0 on 1? Q0 on 1, since we don't have any transition, we are going to put an empty transition, that is absolute. Okay, check here. Q1 on 0 as well as 1 is moving to Q1. So the entries are Q0 on 0 is Q1, Q0 on 1 is absolute, Q1 on 0 is 0, sorry, Q1, Q1 on 1, Q1. Okay, easy. ठीक है, इतना आगे चलें. Shall we proceed? Okay. So the next step is converting the NFA table to an DFA table. For that, we scan the rows in NFA table, and if we'll encounter any problematic term, we'll do the particular steps. Otherwise, we'll copy down as it is. So this is my NFA table. Since in first row, we have a problematic term absolute, right? In DFA, we cannot have empty transitions. So we can't have epsilon in DFA table. So instead of epsilon, I'm going to create a new state. That is Q1 on 0 is moving to Q1, no problem. Q1 on 1 cannot move to the null, right? So we have, I'm creating the new state, say Q2. And we'll see what will be the transition for Q2 on 0 as well as 1. Check here. So this Q2 is new constructed state by us, right? Any problem till here? Okay. What about Q1? Next row. Do we have any problem in the second row? You haven't punched your PRN yet. Is attendance is done? Okay. Let's proceed. So Q1 on 0 is moving to Q1. Q1 on 1 is moving to Q1. So no problem. We'll copy on as it is. Is this okay or something is missing? This table is not complete, so we have to complete the table by giving the transitions for the new state Q2, right? So for time being, we don't know where will my Q2 will go. So we are going to put a loop on Q2. Q2 on 0 will move to itself only, and Q2 on 1 will move to Q2. And since Q2 has no concern with the final state, so no asterisk, no start, same states, Q1 is your final state and Q0 is your initial state. Just we have created one more state, that is Q2, because we cannot have the null transitions in my DFA. So this is my DFA table. Is it okay? The next step to convert the DFA table to the transition diagram. Right? I hope you can convert that. Check here, Q0 on 0 is moving to Q1, that is my final state. Q1 on 0 is moving to Q1, we have a loop. And Q0 on 1 is moving to Q2, that is my new state. What is Q2 here? What is Q2 here? Can we go back from Q2 once we are in Q2? Q2 is nothing but a dead state, right? Since the condition was all these strings will start with 0. So at the beginning only, if you get 1, it will move to the dead state, right? We are going to check on the string starting with 0, right? So this is your complete DFA. Is it okay? Is it clear? Let's check one more example. So we have ending pattern here. You have to construct an NFA over the strings 0 and 1, which will end with 1, right? Tell me Q0 on 0. We have to construct that. Q0 on 0, Q0. Or we can skip 0 as we are concerned with 1, right? Check here. Q0 on 0 will move to Q0 only. This is an ending pattern. So we'll start with the smallest string, that is 1. Q0 on 1 will move to the Q1, that is my final state. Loop कहाँ आएगा? Initial state or final state? Since this is an ending pattern, so we'll be having loop at the beginning, right? Starting में you can have anything, 0 or 1, no problem. But it should end with 1, right? So once we get 1, it will move to the final state. You can have 0 or 1 in the beginning, right? Check here. This is my table. Q0 on 0 is moving to Q0. Q0 on 1 is moving to Q0 as well as Q1, right? Q1 on 0 as well as 1, we don't have any transition. We are going to put at in there. Just a moment. I'm sorry. So this is my NFA table. Since we don't have transition for 0 and 1 on Q1, so we are going to put epsilon there, right? So check in this table, we have both the terms. In both the rows, we have problematic term. In row 1, we have multiple transitions, that is Q0, Q1, and in row 2, we have null transitions. So we are going to deal both of the cases in the same example, right? So check how we are going to convert this NFA table to DFA table. This is my NFA table. Since in row 1 we have a problematic term Q0, Q1, so how we are going to deal with, we consider this Q0, Q1 as a new state and we'll fill the entries for that using the NFA table by taking the union of Q0, Q1, right? So I'll copy down the first row as it is, but we'll consider the Q0, Q1 as a new state. Check here. Is it okay? Now we have to find the entries for Q0, Q1 on 0 and 1. Can you tell me Q0, Q1 on 0, where it will go? Q0 because we are taking the union of this part, right? So Q0 and epsilon, the union of this is Q0, right? And what about Q0, Q1 on 1? Okay, so we'll take union of this part. So it will move on Q0, Q1, right? So Q0, Q1 on 1 will move to Q0. Check Q0, Q1 has a state Q1, which is our final state, right? So we have to make this new constructed state as the final state also, right? So we could start there. Is it okay? Now check the last one. In last row, we have Q1 is moving on 0. It is moving on epsilon. And Q1 on 1 will move to the epsilon. How are you going to deal with new state or no state? Check in this part. Do we have any transition moving on Q1? We have constructed two states, that is Q0 and a new state is Q0, Q1. Do we have anything which is going on Q1? So no one is going on Q1. We don't have any transition on Q1 for 0 as well as 1, right? We have to create this state. If you create this state, we put a loop on it, that will again an unreachable state, right? We have to create this state. Are you getting my point? Since we don't have any transition on Q1, no state, which is Q0 and Q0, Q1, no one of them are moving to Q1, right? And on Q1 also, we don't have any transition on 0 as well as 1. So do we have to create this state? There is no need to create such state, right? If we create that state, there will be single circle at the corner with no transition on it, right? Better we not create that state. So we are going to eliminate Q1 from my DFA table. So that is the complete DFA table. So now we have to convert this DFA table into an DFA diagram. Any doubt here? Why we are not considering Q1? Shall we proceed? Is it clear? Okay. So we'll construct the DFA automata from the table. So Q0 on 0, we move to Q0, so we have a loop. Q0 on 1 will move to the new state, that is Q1, Q0, Q1. So here is your new state, Q1, Q0, and that is my final state, right? We have a transition on Q0, Q1 on 0, will move to Q0. Check here. Q0, Q1 on 1, we have a loop. Okay? Is it clear? Okay, let's proceed. So we have one more example. So this is the definition of your machine. Instead of giving the automata or the language definition, you have described the machine this way. So you know how to read it, right? This is the 5 tuple definition of your NFA. This is nothing but your states. These are your inputs. This is your transition function, initial state, and your final one. This mistake should be a final one. Okay. So, and the transition function is given with the help of table. So we have already have the table. You don't have to create the table. Table is given. So Q0 on 0 is moving to Q0. Q0 on 1 is moving to Q1. Q1 on 1, Q1 on 0 is moving to Q1, and Q1 on 1 is moving to Q0. So we have only single problematic term, that is Q0, Q1, that is multiple states. How we are going to deal it? Check here. We are going to create Q0, Q1 as a new state. To fill the entries, we'll take the union from the NFA table. Can you tell me our new state Q0, Q1 on 0? Where will it go? It will move to Q0, Q1 because we'll be taking the union of these two, right? So Q0, Q1 on 0 will move to Q0, Q1. Q0, Q1 on 1. It will move to Q0, Q1 only because we'll be taking the union of these two, right? Right? So this is my NFA table. Since you can see we have a circle as well as this as a final state. So the final state we are going to put in star. Is it okay? Final state कहाँ से मिला हमें? Definition से मिला. Check here. Check the definition. Can you see the final state in curly braces? That is Q0. So the initial state is also Q0 and the final state is also Q0. Can you read it from here? Is it clear from the definition? These are my total states, that is Q0, Q1. These are input symbols. Transition function is given by the table. This is my initial state Q0 and that is the set of final states, right? Your definition says like this, right? So final state is also Q0 and initial state is Q0. We are going to put an asterisk on Q0. Okay? Since Q0 is the part of your new constructed state, so that will also become a final state, right? So you have two final states. Check here, Q0 along with the arrow, we have two circles because that is the final state also, right? So it has the initial state property with the arrow as well as two concentric circles to repeat that is the final state. So Q0 on 0, yes, Q0 on 0, where will it go? Q0, so you have a loop, right? Q0 on 1, what about Q0 on 1? You move to Q1. We have a transition Q0 on 1 and move to Q1. Q1 on 0, we move to Q1, so you'll be having a loop, right? Q1 on 1, Q1 on 1, we move to the new state, that is Q0 Q1. So Q1 on 1, moving to Q0 Q1, and that is also my final state. So we have two final states here, Q0 and Q0, right? And what about Q0 Q1 on 0 and 1? It will move to Q0 Q1, so we'll be having loop here, right? Check here. Is it okay? Any problem in conversion? NFA to GFA? Shall we proceed? Yes, what's the doubt? Why to remove Q1 in previous example? Okay, just a minute. We're talking about this, right? Okay. So why we are not creating any transition for Q1 here? Check in DFA table if any of these two states is moving to Q1. Do you have any transition moving to Q1? Check in these four entries. Q0 on 0 is moving to Q0. Q0 on 1 is moving to the new state, that is Q0 Q1. And that new state on 0 will move to Q0, and on 1 it will move to itself. So we have no transition on Q1, right? No one of them will move to Q1 on 0 or 1, right? So we don't have any transition going to Q1, as well as Q1 is empty. So we don't have any transition coming out from Q1. Q1 on 0, we are not going anywhere. Q1 on 1, we are not going anywhere. So if you put Q1 here, you have to put a loop, right? So if you want to put, you can put there. So the third row will become Q1, and that will move on 0, Q1, on 1 will move on Q1. But in the transition diagram कैसे रहेगा? ये transition diagram आपने बनाया तो यहाँ पे एक और state आ जाएगा Q1 and with a loop. But वो state पे कोई transition नहीं रहेगा, right? We cannot reach till the Q1 state. So why to draw this? Is it clear why we are not considering Q1 here? Right? Since we don't have any state going to Q1, and neither we have any states coming out from Q1, right? So better we avoid Q1 only. Okay. Anyone else? Is it clear? Conversion. Shall we move to the next topic? Okay. So our next topic is minimizing EFS. What do you mean by minimizing anything?